Finish up 3.5 by looking at example 3. Now we really get into the heart of this, finding all the real and complex zeros. So this is kind of a preview, and we'll dive into it more in this section and in 3.6. So what are all the real complex zeros of this? First things first, go ahead and take your polynomial right here, x cubed plus x squared minus 3x minus 6. You're going to graph it. They've already done it for us here. Remember, the zeros are just x-intercepts. So if I look here, I only see one x-intercept, which looks like it's going to be x equals 2. All right. Now I can confirm that the 2 is a 0 just by plugging in 2 for all the x's. And when I plug it in, I see I do get 0. So I know for sure 2 is an x-intercept, 2 is one of my zeros. But as we'll come to discover, there's potentially going to be 3. Whatever your power is has to deal with how many zeros are going to be. So I'm looking for really 3 zeros, and I've only gotten 1 so far. So there's 2 more answers still to look. So here's what we're going to do next. I'm going to take that answer. I'm going to do the synthetic division. So they already set it up here. They put the numbers in. Let's go ahead and do our synthetic division. Bring down your 1 and so on and so forth. Remember that your last number is always your remainder. So we got a remainder of 0, which again just confirms that 2 does work. And what also allows me to do here is break this down. So we had an x cubed function, and so I divided here. Now I have this leftovers, make my quotient is x squared plus 3x plus 3. So now I have a quadratic, and that's a good thing, because quadratics, I have lots of tools to solve. We could use quadratic formula, factoring, completing the square, getting x by itself and square rooting. We have so many tools. In this case, it doesn't factor nicely, and I would just use the quadratic formula. So if you set it up and use your quadratic formula, you're going to get something like this here. -3 plus or minus square root, 3 squared minus 4 times 1 times 3, all over 2 times a, which in this case, a is 1. If you reduce this, you're going to get, actually this here, so I should have kind of skipped this step here. When you do this square root part, you're going to get the square root of -3. Well, square root of a negative is going to be imaginary. So they pulled out the I from that, and they just left it at square root of 3. Okay. I usually write it as one big fraction, but you could do it this way too. -3 plus or minus I root 3 all over 2 is essentially what you got there. But we do actually have 2 more answers here. So what we really ended up with are x equals 2. We got that from the graph. And then we have these other 2 answers, the plus version and the minus version of this imaginary answer. So we actually do have 3 answers. Let's try that out again. So here we got, they've graphed it for us. Here's our polynomial. We're trying to solve this here, find our zeros. So first up, we graph it, and we get one answer right here. Try that out. Try your synthetic division on this here and see how it goes in getting all your other answers. With this one here, what you're actually going to have to do is do synthetic division twice, since you have 2 answers. So do synthetic division twice. If there's any question that I would love to go over it in class, and we'll see some more examples of that in class and in the next section. But here are the actual answers. Let's see if we can get there. And like I said, I'll help you out in class. All right, we're going to skip over these problems here. We don't need to worry about that. Let's get into solving a polynomial equation. So now we got this big long polynomial, 2x cubed plus 5x squared minus 3x equals 3x cubed plus 8x squared plus 1. Wow, that seems really intense to solve. And there's many different ways of doing it. What they're showing here is you could graph this one in y1 and this one in y1, and we look for the intersection. I don't really like that because it relies on the calculator too much, and also, like, I mean, where are they crossing? They look like they overlap a lot. So let's try it another way. First, let's get it equal to 0. So let's just take this big polynomial here and let's move things from one side. I believe they moved everything from this left side to the right side, like minus 2x cubed, minus 5x squared, added 3x, combine it with certain terms, and we basically get it equal to 0. Okay. Now let's treat this problem like the last thing we did. Let's graph this right here. If you graph it, it looks like this. I'm looking for roots or zeros, or my x-intercepts there. So I should see that from the graph, x equals -1. Crosses right here in -1. Okay, so I'm going to use my synthetic division. Got -1 here. I got my coefficients. I use my synthetic division. That confirms -1 works. And what I have here now is an x squared, because I had x cubed right here. Now I got a 1x squared plus 2x plus 1, and now it's a quadratic. I could use quadratic formula, but I actually did notice this one is actually factorable this time around. X plus 1 and x plus 1. And since it's factorable, I can just set both these equal to 0 and solve. I get x equals -1 and x equals -1 again. So actually what happens here is I do have 3 answers, -1, -1, -1. It's just they have to be all the same answer. So kind of unique situation there. You can definitely try these out. I'm happy to share the answers in class. I didn't put them here. The last idea is getting into an inequality. The good news is you actually have seen this before back in chapter 1. I mean, essentially, I just need to graph this and figure out when is it less than 0, meaning when is it negative or below the x-axis. So we've done that before. What they are demonstrating here is I could take the polynomial and start to factor it, take out a greatest common factor of x. X squared minus 16 factors into x minus 4, x plus 4. So therefore, my zeros or my x-intercepts are going to be at 0, positive 4, and negative 4. Which just confirms it. I mean, this one actually graphs pretty nicely anyways, so I do have my x-intercepts just if I graphed it. So as far as, okay, when is it less than 0, that'd be everything below the x-axis. So like this section right here, this would be everything less than negative 4. And everything in this section here would be between 0 and 4. So everything 0 less than x less than 4. So nothing too complicated there. You just got to graph it and understand which part of the graph you're really looking at. All right, here's a few more you could try out. I'd share answers in class, get a concept summary, and bring questions to class that I could help with.